growth and welfare. As a developing country, building a green, environmentally friendly, and sustainable infrastructure is necessary. The Research Center for Infrastructure and Sustainable Environment aims to answer the challenges to create sustainable and environmentally friendly infrastructure.
The Research Center of Infrastructure and Sustainable Environment, under the Directorate Research and Community Services of Institute Teknologi 10 November, has a goal to create a sustainable infrastructure that has 4 pillars, including environmental sustainability, social sustainability, financial sustainability, and institutional sustainability.
The roadmap of research has focuses on 5 main topics, including mitigation and adaptation of climate change, pollution prevention, built environment, protection of natural resources, and efficiency use of resources and circular economy. More than 80 professional researchers from different expertise are involved in these research centers, such as civil engineering, environmental engineering, architecture, urban planning, chemical engineering, biology, chemistry, and others. We have more than 10 partners at the international levels. At the national level, we provide services for preparing many different environmental analyses, based on our expertise. We also conduct the training course, include on-the-job training.
Research Center for Infrastructure and Sustainable Environment, dedicated to create world-class infrastructure with sustainability and environmental friendly concept. Collaborate with us, be better, together, be greener.
Indonesia is one of the world's largest archipelagic countries that has 17,504 islands. It shows that Indonesia has a lot of maritime wealth and potential resources. DRPM of ITS established the Research Center of Marine and Earth Science and Technology to conduct research or scientific study related to maritime resource optimization in Southeast Asia, mainly in Indonesia.
Welcome to the Research Center of Marine Earth Science and Technology. We are part of the Directorate of Research and Community Services of the Institute Teknologi 10 November as the enlargement of the previous Research Center of Marine Technology. Our research work focuses on the field of marine and maritime technology, as well as geomatics and geophysics engineering. Our present roadmap includes several research such as development of future vessels and marine renewable energies, safety and effectivity of sea transportation, geodynamics, spatial modeling, ecology studies of onshore regions, and development of environmental infrastructures. Member of the center includes lecturers from young and senior lecturers and professors from various departments, and not only from marine technology and geomatics geophysics basis, but also from other departments such as environmental engineering, informatics, and biology. In order to support ITS as a world-class university, we have continuous collaboration with overseas partners such as with University of Southampton, University College London, University Heriot-Watt, University of Melbourne, University Chiba in Japan, and University of the Chinese Academy of Sciences. The fundings of research are coming from Newton Fund Foundation, Australia Indonesia Centre AIC, Global Challenge Research Foundation GCRF UK, Royal Society of Edinburgh RSE Scotland, and Southeast Asia Europe Joint Funding Scheme for Research and Innovation GFSEU. In the era of COVID-19, we make a development of passenger mass detection device of COVID-19 on board ships. Here, one of the book actually, in collaboration with the Indonesian Academy of Sciences, we have a contribution. Last but not least, we are very delighted to work with you to develop any kinds of research and projects in the fields of marine earth science and technology. Thank you.
Disasters and climate change are the strategic issues of concern in urban development and management. Unexpected disasters can come anytime and anywhere. Indonesia was mentioned as a disaster-land country because of the variety and high intensity of disasters. For that, we need to strengthen disaster management with good planning and cooperation from all stakeholders, including universities. ITS developed the Center for Disaster Mitigation and Climate Change Research as a unit that focuses on research from various sciences to reduce the risk of disasters and climate change.
The Research Center for Disaster Mitigation and Climate Change, or PUSIT MKPI, is under the Directorate of Research and Community Services (DRPM) in ITS. MKPI offers ideas, solutions, technologies, and models in disaster and climate risk reductions based on a comprehensive and thorough research and outreach programs. The MKPI Research Center is supported by research members from various departments at ITS with master, doctoral, and professor, with research themes that are in line with the MKPI roadmap. The roadmap includes flooding, earthquake, tsunami, landslide, mud volcano, capacity buildings, disaster rapid assessment, temporary shelters, climate change, and sea level rise. In the development of science and technology, MKPI takes an active role in various forms of activities, such as making research collaboration by involving researchers from various departments and partners, both at home and abroad, conducting research activities by looking at the realities of the needs in the field, and prototyping of disaster risk reduction technology products, such as earthquake preparedness strategy for Surabaya, collaboration with Surabaya government and the UK government, the impact of solar radiation management from UNESCO, TWS, estimation of CO2 emissions in the peatland region of South Borneo, funded by Japan, Asian Science Technology, urban flood risk assessment and loss analysis with a 3D visualization method, collaboration with Chiba University, Japan, develop tools for earthquake simulators, low-risk spatial plan model, and real-time flood monitoring, and then the 3D evacuation map for people with disabilities. So we invite all of you to collaborate with us in ITS. Thank you very much.
Globally, one of the challenges for developing countries is to provide excellence and world-class infrastructure. It is a part of the global goals known as Sustainable Development Goals or SDGs. Several of the goals are related to sustainable infrastructure, such as number 6 about clean water and sanitation, number 9 about the industry, innovation and infrastructures, number 11 about sustainable city and community, number 12 about responsible production and consumptions, and number 13, 14, 15 about climate change, life below water, and life on the land. Since 2015, Indonesia has started focusing on massive infrastructure building to support economic growth and welfare. As a developing country, building a green, environmentally friendly, and sustainable infrastructure is necessary. The Research Center for Infrastructure and Sustainable Environment aims to answer the challenges to create sustainable and environmentally friendly infrastructure.
The Research Center of Infrastructure and Sustainable Environment, under the Directorate, Research and Community Services of Institut Teknologi 10 November, has a goal to create a sustainable infrastructure that has 4 pillars, including environmental sustainability, social sustainability, financial sustainability, and institutional sustainability.
The roadmap of research has focuses on 5 main topics including mitigation and adaptation of climate change, pollution prevention, built environment, protection of natural resources, and efficiency use of resources and circular economy. More than 80 professional researchers from different expertise are involved in these research centers, such as civil engineering, environmental engineering, architecture, urban planning, chemical engineering, biology, chemistry, and others. We have more than 10 partners at the international levels. At the national level, we provide services for preparing many different environmental analyses, based on our expertise. We also conduct the training course include on-the-job training.
Research Center for Infrastructure and Sustainable Environment, dedicated to create world-class infrastructure with sustainability and environmental friendly concept. Collaborate with us, be better, together, be greener.
Indonesia is one of the world's largest archipelagic countries that has 17,504 islands. It shows that Indonesia has a lot of maritime wealth and potential resources. DRPM of ITS established the Research Center of Marine and Earth Science and Technology to conduct research or scientific study related to maritime resource optimization in Southeast Asia, mainly in Indonesia.
Welcome to the Research Center of Marine Earth Science and Technology. We are part of the Directorate of Research and Community Services of the Institut Teknologi 10 November as the enlargement of the previous Research Center of Marine Technology. Our research work focuses on the field of marine and maritime technology, as well as geomatics and geophysics engineering. Our present roadmap includes several research such as development of future vessels and marine renewable energies, safety and effectivity of sea transportation, geodynamics, spatial modeling, ecology studies, of onshore regions, and development of environmental infrastructures. Member of the center includes lecturers from young and senior lecturers and professors from various departments, and not only from marine technology and geomatics geophysics basis, but also from other departments such as environmental engineering, informatics, and biology. In order to support ITS as a world-class university, we have continuous collaboration with overseas partners such as with University of Southampton, University College London, University Heriot-Watt, University of Melbourne, University Chiba in Japan, and University of the Chinese Academy of Sciences. The fundings of research are coming from Newton Fund Foundation, Australia Indonesia Centre AIC, Global Challenge Research Foundation GCRF UK, Royal Society of Edinburgh RSE Scotland, and Southeast Asia Europe Joint Funding Scheme for Research and Innovation GFSEU. In the era of COVID-19, we make a development of passenger mass detection device of COVID-19 on board ships. Here, one of the book actually, in collaboration with the Indonesian Academy of Sciences, we have a contribution. Last but not least, we are very delighted to work with you to develop any kinds of research and projects in the fields of marine earth science and technology. Thank you.
Disasters and climate change are the strategic issues of concern in urban development and management. Unexpected disasters can come anytime and anywhere. Indonesia was mentioned as a disaster-land country because of the variety and high intensity of disasters. For that, we need to strengthen disaster management with good planning and cooperation from all stakeholders, including universities. ITS developed the Center for Disaster Mitigation and Climate Change Research as a unit that focuses on research from various sciences to reduce the risk of disasters and climate change.
The Research Center for Disaster Mitigation and Climate Change, or PUSIT MKPI, is under the Directorate of Research and Community Services (DRPM) in ITS. MKPI offers ideas, solutions, technologies, and models in disaster and climate risk reductions based on a comprehensive and thorough research and outreach programs. The MKPI Research Center is supported by research members from various departments at ITS with master, doctoral, and professor, with research themes that are in line with the MKPI roadmap. The roadmap includes flooding, earthquake, tsunami, landslide, mud volcano, capacity buildings, disaster rapid assessment, temporary shelters, climate change, and sea level rise. In the development of science and technology, MKPI takes an active role in various forms of activities, such as making research collaboration by involving researchers from various departments and partners, both at home and abroad, conducting research activities by looking at the realities of the needs in the field, and prototyping of disaster risk reduction technology products, such as earthquake preparedness strategy for Surabaya, collaboration with Surabaya government and the UK government, the impact of solar radiation management from UNESCO, TWS, estimation of CO2 emissions in the peatland region of South Borneo, funded by Japan, Asian Science Technology, urban flood risk assessment and loss analysis with a 3D visualization method, collaboration with Chiba University, Japan, developed tools for earthquake simulators, low-risk spatial plan model, and real-time flood monitoring, and then the 3D evacuation map for people with disabilities. So we invite all of you to collaborate with us in ITS. Thank you very much.
Salam tangguh. Respon awal bencana mandiri penting dilakukan agar dapat mengurangi potensi dampak buruk yang mungkin terjadi. Video ini merupakan contoh simulasi respon awal mandiri di sekolah disabilitas dengan siswa dan beberapa guru netra. Respon awal bencana adalah bagian dari siklus manajemen bencana. Rangkaian kegiatan dalam respon awal ini dilakukan secara mandiri oleh penyintas dan kelompok masyarakat segera setelah terjadi peristiwa bahaya atau yang berpotensi menjadi bencana. Diawali dengan peringatan bahaya, diikuti dengan aksi-aksi respon darurat lainnya dengan prioritas pada penyelamatan dan evakuasi. Peringatan bahaya adalah tanda yang disepakati bersama untuk segera melakukan penyelamatan diri ketika terjadi peristiwa bahaya. Peringatan bahaya pada peristiwa gempa adalah guncangan gempa itu sendiri. Ketika merasakan guncangan gempa, segera berlindung. Tetap tenang, tunggu hingga kondisi memungkinkan untuk menyelamatkan diri atau tunggu arahan lebih lanjut. Lakukan tindakan merunduk, berlindung, berpegangan. Tetaplah tenang sambil menunggu arahan lebih lanjut atau kondisi memungkinkan untuk tindakan penyelamatan diri. Saat berlindung, usahakan saling menenangkan. Jika memungkinkan, berlindung di bawah perabot yang kokoh seperti meja atau kursi. Bila tidak ada tempat berlindung, lindungi kepala dengan lengan Anda, merunduklah serendah mungkin. Bantu pengguna kursi roda untuk melindungi kepalanya. Pada proses respon awal ini, rangkaian tindakan dilakukan secara simultan dan bersamaan. Terbagi dalam respon aksi tim siaga sekolah dengan aksi gabungan bersama tim 112. Aksi respon awal dimulai dengan aktivasi dan mobilisasi tim siaga sekolah. Diikuti dengan menggunakan alat pelindung diri serta mengambil persediaan logistik berikut peralatan respon darurat awal lainnya. Persiapan evakuasi. Lakukan evakuasi mandiri setelah guncangan gempa berhenti. Bergerak dengan tenang, waspada, dan tetap lindungi kepala. Jangkau titik kumpul terdekat terlebih dahulu, tunggu beberapa saat hingga keadaan memungkinkan untuk bergerak ke titik kumpul akhir. Sebelum melakukan evakuasi mandiri, periksa keadaan siswa terlebih dahulu. Asumsikan siswa terluka bila tidak merespon saat dipanggil. Dalam keadaan kritis dan terjebak, bunyikan fluid atau sumber suara keras lainnya untuk mendapatkan pertolongan. Dalam keadaan mendesak, lakukan tindakan pertolongan pertama sesuai dengan kemampuan yang dimiliki. Komandan tim siaga sekolah melaporkan keadaan kepada 112. Laporan ini untuk mengintegrasikan respon awal sekolah dengan sistem tanggap darurat kota. Regu evakuasi juga bertugas melakukan penyisiran sekaligus menenangkan warga sekolah yang terjebak agar tidak panik hingga tim penolong datang.
Baik-baik saja. Ini Kiki, Mbak. Rama sedang pingsan dan Rafli terluka. Oke Kiki, Mali akan segera cari bantuan. Tetap tenang ya.
Komandan tim siaga sekolah melaporkan perkembangan keadaan kepada 112 berdasarkan laporan regu evakuasi agar dukungan yang diberikan sesuai dengan kebutuhan. Setelah keadaan memungkinkan, segera menuju ke titik kumpul akhir. Bergerak bersama dengan tenang, waspada, dan lindungi kepala. Tindakan awal yang dilakukan di titik kumpul akhir adalah triase, yaitu pemilahan berdasarkan kondisi masing-masing untuk kesesuaian penanganan lebih lanjut. Label hijau untuk kondisi ringan, label kuning untuk kondisi sedang, dan label merah untuk kondisi parah atau kritis.
Mohon menyampaikan untuk terjadinya gempa yang menyebabkan terjadinya reruntuhan dan ada korban di situlah di DRP Jalan Dibangun nomor 5. Mohon segera menyelesaikan.
Sebelum aksi respon gabungan dilakukan, tim 112 berkoordinasi dengan tim siaga sekolah terlebih dahulu. Mobilisasi tim penolong 112 seperti tim kelurahan, pemadam kebakaran, dan Palang Merah Indonesia merupakan irisan dan sinergi antara respon penanganan awal di sekolah dengan tim tanggap darurat kota yang sesuai dengan kebutuhan penanganan di sekolah. Penanganan bersama yang dilakukan ini adalah melakukan penstabilan, menenangkan, dan perawatan dasar lain yang diperlukan sebelum dirujuk ke tempat pelayanan kesehatan lebih lanjut. Tim 112 bersama tim siaga sekolah merujuk korban luka yang memerlukan penanganan lebih lanjut ke pelayanan kesehatan terdekat dengan didampingi guru. Keadaan aman dan terkendali, seluruh koordinator menyampaikan laporan akhir kepada Komandan Tim Siaga Sekolah. Berdasarkan laporan para koordinator, Komandan Tim Siaga Sekolah mengambil keputusan untuk pengakhiran kegiatan respon awal. Beberapa pilihan keputusan kembali ke kelas dan melanjutkan kegiatan belajar, pemulangan siswa, penyatuan keluarga, dan penutupan sekolah untuk sementara, atau berlindung dan tinggal sementara di sekolah. Pelaksanaan keputusan ini dilakukan pada aksi tanggap darurat selanjutnya. Simulasi ini adalah sebuah percontohan peningkatan kemampuan melakukan respon darurat awal di sebuah kelompok sosial dengan pendekatan 5 mandat inklusif, yaitu data pilah, aksesibilitas, partisipasi, prioritas perlindungan, dan peningkatan kapasitas agar dapat meningkatkan peluang keselamatan yang lebih besar.
Please hold the strong seat first and then switch your mobile phone to silent avoid interruption. Thank you for your attention.
Yang terintegrasi dengan sistem 112 Surabaya. Simulasi ini memberikan gambaran respon awal sesaat setelah gempa yang menjawab kebutuhan dan tindakan khusus yang diperlukan. Reaksi yang terjadi bisa sangat beragam, seperti terluka, tidak sadarkan diri, atau bahkan bisa menjadi penolong. Sehingga dengan bersiap lebih baik, maka seluruh warga di kelompok ini dapat bersikap tenang, selamat, dan risiko berkurang. Kami berharap proses ini dapat dikembangkan di kelompok-kelompok sosial lainnya, tidak hanya di sekolah, tetapi juga di RT, RW, kantor, perusahaan, dan sebagainya, sehingga pada akhirnya dapat menjadi kesiapsiagaan bencana berbasis komunitas di Surabaya.
Sebagai kota metropolis, melihat aktivitas masyarakatnya sangat dinamis, tidak terkecuali di kawasan pemukiman penduduk. Untuk itu, pemerintah kota Surabaya berupaya terus mengembangkan kawasan pemukiman penduduk menjadi lingkungan pemukiman yang hidup, inklusif, dan berkelanjutan. Saya menyambut baik program Global Future City Prosperity Fund ini dalam rangka sinergi bersama segenap stakeholder yang ada di kota Surabaya menjadi lingkungan yang hijau serta komprehensif yang dapat membawa dampak positif bagi masyarakat dan lingkungan sekitar.
However, this rapid development of Surabaya also bears a certain risk. Global Future Cities Program Earthquake Preparedness Strategy for Surabaya is an intervention to support Surabaya's city government and the relevant stakeholders in transforming the city into a safer place to live for the citizens with respecting inclusion mandate. Establishing resilient and inclusive communities, where no one is left behind when a disaster occurs, is a core component of disaster risk reduction. Not everyone faces the same risk from disasters. Leave no one behind.
Assalamualaikum warahmatullahi wabarakatuh. Before starting today's event, we would like to express our sincere gratitude to Excellency Professor Dr. Setiawan, SD, MEng, at the head of the Sub-Directorate Research and Scientific Publication. Excellency Mr. Fadlul Fani, SDPhD, at the Director of Research and Community Service. Excellency Speaker Dr. Bagus Nugroho from Redbird University, Professor Antonio Swanto from IPB University, Dr. Amin Widodo from School of November Institute of Technology, Dr. Mohsen Wong from Crampton University, and the respectable all-invited guests and the honorable all participants of Sustainability and Resilience of Coastal Management 2022. First of all, let's thank the organizers of Allah Subhanahu wa Ta'ala who has given us the blessing and blessing so that we can attend this event and install a set of titles. Secondly, salam and salam will always be given to our Prophet Muhammad, who has led us from the darkness to the lightness. Ladies and gentlemen, I would like to say welcome to Sustainability and Resilience of Coastal Management 2023. Thank you very much for your taking time to attend this seminar. I am Setia Zaina Azim Isma as the Minister of Ceremony today. I would like to read the is of me. The second agenda is sending the national anthem in Indonesia Raya. The third agenda is welcoming speech by Professor Dr. Amin Widodo at the head of the Sub-Directorate of Research and Scientific Publication. The fourth agenda is welcoming speech by Professor Muhammad Berchandiyadi as the Chairman of SRCM 2023. The fifth agenda is presentation from the speaker, Dr. Bagus Nugroho, Professor Antonio Swanto. The sixth agenda is first panel session. The seventh agenda is break. The eighth agenda is second panel session. The ninth agenda is solving break. The tenth agenda is presentation from the speaker, Dr. Amin Widodo and Dr. Mohsen Wong. And the last agenda is one speech by Mr. Fadlul Fani as the Director of the Directorate of Research and Community Service. Well, before beginning the agenda, let's open the seminar of Sustainability and Resilience of Coastal Management 2023 by reciting the salam together. Bismillahirrahmanirrahim. Thank you very much for the agenda rundown. Now we are going to the second agenda, deliver our national anthem, Indonesia Raya. Honorable from all audience, please stand up.
Jadi pandu hidupku, Indonesia kebangsaanku, bangsa dan tanah bangsaku, rakyatku semuanya, bangunlah jiwanya, bangunlah badannya, untuk Indonesia Raya. Indonesia Raya, merdeka, merdeka, anakku, negeriku yang ku cinta. Indonesia Raya, merdeka, merdeka, hiduplah Indonesia Raya. Indonesia Raya, merdeka, merdeka, anakku, negeriku yang ku cinta. Indonesia Raya, merdeka, merdeka, hiduplah Indonesia Raya.
All audience, have a seat please. Thank you very much. Yes, now we welcome the speech as local as the child to deliver his talk.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The Honorable Vice Director of Director of Research of Communities Service, DRPM, DS, Professor Agung Kurniawan, our keynote speaker, Professor Antonius Wanto from IPB University, Honorable keynote speaker, Professor Liang Feng from Cranfield University. Keynote speaker also Dr. Ami Widodo, and our participant today. Also our head of Research Center for Marine and Earth Science, Professor Putut Priya Utama, also Budian, Organizing Committee and Steering Committee. All of participants in this room and also in online, in the Zoom online. Participants, our seminar today is international seminar for SRCM. It's Center for Sustainable 2003, which is Sustainability and Resilient Coastal Management. This is annual seminar. We start from 2020, then 2021 and 2022. All of the conference seminar is in online because of the COVID-19. And this is first time we do in the hybrid conference. And also, as the 3 years ago, 3 seminar in 2020 until 2022, all of the proceeding is will publish in the Scopus Index. Not sure, but we will try. And because of that, we hope all of the speaker parallel sessions and who contribute in the seminar and the proceeding should make good paper for the publication, because this is different from year to year, focus on improve the quality. In this three, SRCM 2023 consists 7 countries with 52 abstracts and will improve until December this year or make publication. So this being good in the paper conference. And we divide to the 14 topics. Yeah. We will start during seminar today. Therefore, we hope all of the researchers can contribute their knowledge in this seminar. We really hope that the existing paper can increase scientific contribution and research output. As chairman, I would like to express my deepest appreciation to Professor Anthony Suwanto from PPB University for the keynote speaker, also Professor Ikut Utama, Scientific Committee and Organizing Committee, all of the students. And we hope that our Vice Director of Directorate Research and Community Service, Professor Agung Kurniawan, to open the event. So thank you very much, all of the participants. Assalamualaikum warahmatullahi wabarakatuh.
For your full speech. As agenda will be a very speech, so Professor Dr. Agung Kurniawan, as the head of the Directorate of Research and Scientific Publication, to the Please welcome him. Please welcome.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good morning. I am truly honored and delighted to welcome you to International Conference, the 4th Sustainability and Resilience of Coastal Management. It is a privilege to stand before such a distinguished and diverse gathering of scholars, professionals, and thought leaders from around the world. First and foremost, I extend my warmest welcome to our esteemed keynote speakers, Professor Antonius Suwanto, Dr. Bagus Nugroho, Dr. Lau Feng Huang, and Dr. Amin Widodo, whose expertise and insights are sure to set the tone for an intellectuality stimulating conference. We are grateful for your presence and eagerly anticipate your address. I would also like to express my sincere gratitude to all the SRCM 2023 committees, the scientific committees, and organizing committees from the Research Center for Marine and Earth Science and Technology, STKK, this Center for Disaster Mitigation and Climate Change, NKPI, this Center for Infrastructure and Sustainable Environment, ILD, whose support has been instrumental in making this conference a reality. Your commitment to the advancement of knowledge and the promotion of collaboration is truly commendable. Today, we are very proud and grateful for holding the 4th SRCM in 2023. As stated by the chairman of the committee, SRCM is an annual agenda organized by 3 research centers: the Research Centers for Marine and Earth Science and Technology, Research Center for Disaster Mitigation and Climate Change, and Research Center for Infrastructure and Sustainable Environments. Of course, we are very grateful because the knowledge at the three research centers are accommodated in international conference, as well as helping ITS to increase the number of publications at reputable international seminars. We also greet to SRCM 2023 participants from various countries who are the main author and co-author in the SRCM 2023 International Seminar, mainly from Malaysia, Germany, Japan, and others. We really appreciate and contribution of researchers to provide scientific contribution, especially in the field of sustainable and resilient coastal management. By saying Bismillahirrahmanirrahim, we officially open this 2023 SRCM International Seminar. Congratulations on carrying out the dissemination of science and technology, especially those related to the research center above. Hopefully, it will be useful for advancing humanity as one of the noble goals of our ITS campus. Once again, congratulations on holding this international seminar. Hopefully, there will be more benefit for science and technology. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Professor Dr. Abu Bakar for your speech. Let's enjoy our moment to help you this agenda. Next to hear keynote speech, who will be looking for our moderator, Professor Insinyur Utama, MSc PhD, CM Rina Haidi. First of all, allow me to introduce our moderator, Professor Insinyur Utama. Complete his undergraduate studies at ITS, followed by her master's and doctoral degrees, but also at University of Southampton. Currently, Professor Dr. Utama serves as head of the SRCM Research Center and Professor of Naval Assistance with a certification in hydrodynamics. Ladies and gentlemen, please join me in welcome Professor Insinyur Utama, MSc PhD and Rina Haidi. Ladies and gentlemen, our first speaker is Dr. Sugro from Harvard University, and our second speaker is Professor Anu Sumanto from IPB University. We invite all the speakers to come to the stage, please.
Good morning, ladies and gentlemen. Welcome to the SRCM 2023. As mentioned by the MC, my name is Arya Priyatama. I am now the moderator for the two keynote speakers in the morning. First, Dr. Bagus Nugroho, and second, Professor Dr. Bagus Nugroho is a lecturer at Melbourne University in Australia, and second, Professor Antonius Manto from IPB University. First speaker will be Dr. Bagus Nugroho. Please, could you connect to Dr. Bagus Nugroho? Already.
Yeah, I can hear you clearly.
Okay. Good morning, Pak Bagus Nugroho. Thank you, for your time with us. So, what time is in Melbourne?
Currently it's 20 minutes past 1, so 1:20 p.m.
Okay. Thank you, Pak Bagus. I just want to introduce Bagus Nugroho. So Dr. Bagus Nugroho is a lecturer at the Department of Mechanical Engineering, the University of Melbourne in Australia, and part of the Fluid Mechanics Research Group. His research interest is in fundamental fluid mechanics, both in experiment and numerical simulation, particularly on high Reynolds number in flows, flow controls, drag reduction mechanism, and rough to-bridge flows. He also looks into environmental flows such as the effects of biobolic on fluid engineering application, collapsing and submarine and high emission wind turbine. The further growth is also involved several defense-based applied research such as unmanned combat aerial gyroaerodynamics and morphing wings, submarine hydrodynamics, and helicopter landing pad hydrodynamics on naval destroyer. So I think I pass the time for Dr. Nugroho. So your time about 30 minutes to talk, Pak Bagus, and followed by question and answer with the audience, both offline and online. Okay, please, Pak Bagus.
Okay, great. 30 minutes here. Okay, let me just share my screen, desktop, and I'll open the entire page. All right. You can hear me and see it clearly, yeah? Pak Ketut, Prof. Ketut, you can hear me, yeah? Okay. All right. So, I think I will start. So this is a joint work between the three institutions, especially with ITS. So it started in 2015. I started working with Professor Ikap in 2015, but many of the data that I'm going to show you here they are new and it's only recently showcased. And actually, this is only the second time that we show the new data in public because it's not published yet. Okay, so there's many interesting new insight coming from this. It's been a long process. All right, so let's start. Now, as I mentioned with my title, the title of my work is mostly about roughness, the roughness effect of roughness on a ship. Now, if we have a ship like this, it's a large tanker ship, okay? And it's moving, it has a propulsion system, so it's moved with the velocity u from the right to the left. It will have what we call the boundary layer. If you can see this blue, the blue image on the bottom, that's what we call developing boundary layers. It's everywhere in a ship, in an airplane, in a pipe, or any fluid flow, any wall-bounded fluid flow. And this developing turbulent boundary layer is actually responsible to the bulk of the drag experienced by a large ship, for example, like this one. About 80 until 90% of the total drag by a large bulk carrier is due to the skin friction drag, and the rest, about 10 until 20%, is from the shape of the hull. But skin friction drag is the dominant force in drag. Okay. Now, the issue of this skin friction drag is even made worse due to surface roughness. Like, for example, in the bottom of a ship, okay, we have these things like biofoulings that grow, okay? So many of the roughness associated either with biofoulings or hull imperfections. Even the act of painting the ship itself, like I'm gonna show you, doesn't necessarily mean that your ship is actually smooth and what we call clean per se, or hydrodynamically smooth from the boundary layer point of view. Now, so even a recently cleaned ship hull will experience what we call a surface roughness. Okay. Now, so there are about 50,000 ships currently in operation. The bulk, the big one, the big ships. Okay, there are more actually, the smaller one. they're burning about 5 million barrels of oil per day, about 5% of the global production. And the ship industry is responsible to about, well, 3 until 4% of greenhouse emission. But this is an old data. This is 2019 paper. If it's 2019 paper, so most of the data like usually 5 years until a decade before. So I can assure you that number is higher today, especially post-COVID era. Okay. Now, and here's the thing: 80 until 90% of this 3 or 4% of the global one is from unfouled hull. So even a ship that is clean, okay, I told you it's generating drag, and many of the ship that operating now, especially the big carrier, that tend to have a good anti-fouling paint. So they are now already have their hull is actually clean, what we call it. There is no biofouling, okay. But as you can see later, it still has pretty bad consequences. Now, so 90% resulting from an unfouled hull. So this is when I visited a typical shipyard. So this is the ship belonged to Samudra Indonesia. Okay, the owner of the Samudra is actually a close friend of me. So that's why they allow us to do experiments on them. Okay, so this is a continuity of our previous works with Professor Ketut. So in the past, we did experiment with ferry, a wonderful ferry, but now we tested on a much larger ship. So the experiment is still ongoing. It's not finished yet. Okay, it's the one that we start in 2015. This is a further development. So this is a new, recently clean ship. It's a brand new ship, just 5 years old, made in Japan. This is their first dry docking. And if you will look closely near the surface, as you can see, they are not smooth. They have these patches, okay? That's what we call the orange peel pattern. It's the effect from the painting itself. Before they did the paint, they clean it up all the way to the bare hull. So it's up to the steel skin, okay? Really clean, okay? It's just a gray steel. So then they put it, and they put paint, anti-corrosion, and then anti-fouling paint. Despite the careful work, this is what happened, and this is quite common. And actually, this is already one of the best quality painting application around. We've shown this to our colleagues, Professor Mike Schultz from the U.S. Naval Academy. He's one of the world's expert in biofouling, and he showed, oh, that's really nice painting. That's one of the best, Bagus. So he told us that. So this is an example of one of the best anti-foul, painting, cleaning and painting available anywhere in the world, applied to a brand new ships, less than 5 years old ship. Okay. Now, but this is when the ship when it first came in. So when it first came, we look at it when it's first died drop. Indeed, there were biofoulings like this. Okay, as you can see in the image. But this is still okay. I've seen many cases, or many of you have seen cases, that it's fully covered with biofouling. You can't even see the hull paint anymore. This one is still considered, after 5 years or 4 years, 4 until 5 years on the water, this is still pretty okay. Okay, so it's one of the clean one, actually. Many ships experience worse situation. Okay, now, so for the shipping industry, the problem is economic. Cleaning and recording is expensive. Dry dock cost, oh, that's even expensive. I think Professor Ketut will, Professor Ikap will know more this about than me. I don't know, Professor, what is it? What, $10,000 per day or something ridiculous amount of cost, something like that. And the ship is not making money. Okay, while the IMO wants to have cut the emission of 40% of the 2008 level by 2030. Ooh, that's a lot of that's a tall orders, but we'll see. Okay, so this is what they actually want. But the problem is currently the emission is it's increasing, so they really want to push it down. Okay. Now, but the problem is not cleaning your ship is quite expensive. It costs your ship more fuel, as I'm going to show after this. Okay. Now, Another problem is that the accurate prediction of a drag penalty of ship hull is lacking. So one of the first estimation, like predicting drag penalty, was carried in 1980 by Professor Alan Townsend. If I'm not mistaken, his name is Townsend, Professor Alan Townsend from Newcastle University, I think, in the 80s. So he created a prediction method to predict how much the drag due to a ship hull. Now, I understand why he wanted to do that, because it's quite difficult to estimate drag of a ship. You need to do experiment on it. Now, but that his method received a lot of criticism, especially by Professor Grigson. Okay, so Grigson is a fluid dynamics purist, and he believed that drag prediction has to be based on proper boundary layer theory. But boundary layer theory is at that time is still it's, especially with the roughness, it's still like a lot of stuff still, and to do it you need a lot of long experiment. And remember, this is 80s. There's not even computer simulation. It's not even ready yet. Okay, so there's those two giants in the field of shipping and hydrodynamics, they have a lot of clash. So if you look at the paper on the 80s between those two gentlemen, you will see it's quite fascinating the way they riposte to each other. Okay, now the goals of this research is that we want to improve the estimation method that Professor Townsend developed in the 1980s, but we need to be based on a sound boundary layer theory. Okay, because many of the theory, although it's good, is still the error that general is still quite large. But at that time, that's the best that we have. Actually, that method is still used until now. It's still endorsed by ITTC. Okay, now, and we also do a test and improve the full-scale predictive capability of our lab experiments. Okay, so there are two activities that we do. Okay, full-scale measurements experiment on a ship and a laboratory experiment. There will be a third one, which is computer simulation. It's not here. It's not this yet. It's still being planned. The computer simulation will be conducted by Professor Ikap and his team at ITS. Okay, based on the finding of this lab and full-scale measurements. Okay. We hope that the computer simulation, the number 3, will start next year, okay, in ITS. Now, so I'm going to start from number 2 first, lab experiments, okay? So this is how we normally do, okay, a proper way to predict the drag of a ship, okay? And some people think that there is an argument. Some people think this way better, that way better, but in the community, in the shipping and fluid mechanics community, they start, especially in the last 10 years, they start believing this is maybe the most proper way to predict dress in laboratory experiments. Okay, now note that the experiment that I use in here is based on my old work and also together with Professor Ikap in 2015. So it's not from the big ship. Okay, this is the previous data. The lab experiment for the current ship, the large Sinar Samudra Indonesia ship, is gonna be started next year. Okay, so this is an old data that we did. Now, so what we did is that we did an imprint of the surface of the hull of a ship. This is what it looks like, and you can see the orange peel pattern. So what we did, we put an imprint, and then we laser scan it, and then we can get all of the 3D data. Afterwards, we replicate it and manufacture it in CNC and put it on our wind tunnel. This is the wind tunnel at the University of Melbourne, the small one, close to 7 meters working section. Okay, and so we have this type of pattern, and then we about half a meter by 30. Sorry, yeah. Half a meter by close to 30 centimeters, and then we put it on the bottom of our wind tunnel, and we fill the tunnel with all of this roughness. Okay, and then if I zoom this thing in, and then we do an experiment using hot wire anemometers covering all of those grids. So we do about 50 wall normal and about 20 span-wise, okay? And then we combine those into one, okay? And this is what we got. Okay, this is what we call the mean velocity profile. We're using a log law. If you're not familiar, don't get confused. It's just easy. The vertical axis is the velocity. The horizontal axis is wall normal distance. So basically, I'm just pulling the sensors from the surface all the way up. That's what it means. The distance, so vertical is vertical axis is velocity, horizontal axis is distance. And we non-dimensionalize it, okay? So we make it non-dimensionalized so that it can be analyzed universally. So that's why you do not see meter per second here, or you do not see meter in here. We non-dimensionalize it. So this is a data from a smooth wall. If you have a smooth surface and you measure the mean velocity profile of the turbulent flow this is what you get. The pattern will make this unique shape. So this is semi-logarithmic. So log in the x-axis and linear in the y-axis. And we force them to fall under this universal log law, okay? That universal log law has been through a lot of trial and tests in the last 100 years, but I think in 2013, Professor Ivan Maruzic from Melbourne Uni, together with Professor Jason Monti, plus Professor Lex Smith from Princeton, they put the nail on the coffin once and for all that, yes, they got data from high Reynolds number, and yes, this log law hold. So this is a smooth wall, and then this is just near the wall. And then what happened to the wall? Noise. Right. All right. Now, so this is a smooth wall. But what happened with the rough wall? This is rough, like as you can see, there is this orange pill pattern. Okay. So we did measurement on them. So this is a smooth wall, and this is the rough wall at 10 meters per second. So we vary the speed of the wind tunnel. So 10 meters per second. And then as you can see, this thing fall down slightly. As you can see, this is the line, and then at rough wall 10 meters per second, there is a drop called over a distance of delta U plus. Okay, and then as we increase the velocity, it's gonna go down, down, and down. What is delta U plus? Delta U plus is basically indicating that the flow is experienced increase in drag. So in other words, that ship, okay, that ship that recently cleaned already experienced drag. Okay, now the question is, how bad is the increase of the drag? Okay, now the velocity profile already shown you is a drag increase, but by how much? Now, once we got the delta U plus, okay, we need to plot another function, what we call Hama roughness. So this is what we call Hama roughness function, this delta U plus, okay? So basically, it's a unit of a viscous scale roughness height. Now, we took this data, so we got delta U plus, and then I'm taking this data and I plot it into here. The vertical axis, again, axis is delta U plus, so this value, okay, this delta U plus value, the distance, it's shifted from the smooth to the rough. We pull it here in the vertical axis, and the horizontal axis, we call this Ka. Some people calling Ks plus, and I'll talk about it later. And then we pull a line. This is again a universal line by Nikuratsi in 1930s, if I'm not mistaken. And this is the equation of the line. And then from this CKA, from this CKA, we will get what we call Ks. Now, before I go further, what is this Ks? So Ks is basically the currency of roughness. How rough a surface is defined by the Ks value. It can be anywhere from 100 micron to several centimeters. And to put it into perspective, Ks is actually not much different with the sandpaper. If you go to, I don't know, in Australia it's bunning, in Indonesia is what do you call that thing where you can buy building equipment and stuff like that. I forgot the name. Just like a toko kelontong kayak gitu maybe. So if you go to any shop like that and you buy sandpaper, if you look at the back, you can see it, right? P10, P20, P30, 40, 50. The higher the number, the smoother the sandpaper, right? So think of it like that. Okay, so that KS is almost the same like a sandpaper. Okay, because that's how they did it in the 1930s. Now, so the KS is about 100 micrometers. Now the question is this 100 micrometer is significant or not? Let's put it this way. Professor Mike Schultz believed on his famous paper in 2007 that a good painting should be 30 micrometer. Okay, 30. Okay, so a recently painted should be 30 micron. Okay, so this is already 3 times higher. Okay, but again, when Professor Mike Schultz, when we contact him, how do you get that 30 micron? He said that that's for a brand new steel when it's applied properly, brand new. Okay, so and this is a 5 years old ship. Actually, my data, this is taken from a 40-year-old ship that regularly clean. That's already like this. Okay, this is 30 years old ship. Okay, now so from that data, once you got the KS, you can build what we call something that more familiar for hydrodynamicists, like many of you, is the CF versus REL. Okay, the Reynolds number of the base on the length of the ship, and this is the smooth wall. Okay, if it's a smooth surface, this is what it looks like. I think many of you, even the students, familiar with this. But for a rough ship, okay, for this orange peel pattern that I did experiment for, this is what it will go. So it will be shifted up. Okay, now this is the general one. What about if it's from a cargo ship or a tanker ship? Okay, this is what we will get. Okay, so for a cargo ship with or a tanker with I don't know, this is 10 to the power of what is it, a billion? Yeah, Ariel close close to 2 billion or something, 10 to the power of 9. Okay, the CF, okay, the coefficient of friction is already 24%. So a ship that just recently cleaned and painted will already experience this. Okay, so now you can see how difficult it is to battle and to save energy, right? So it's quite challenging. Now, that's the experiment that we did. Okay, what about on the actual ship itself? Okay, the challenge with this experiment is that it took me in a wind tunnel, took me like 3 weeks, 2 or 3 weeks to do this experiment. This experiment, when you do mean velocity profile like this one, this or this, each of them will take 4 until 5 hours, and you normally need to repeat it 2 or 3 times. So I got, how many is this? 1, 2, 3, 4, 5. Okay, 5 multiplied by 4 until 5 hours, 25 hours each, and I replied and then tried like 5 or 6 times. You can see that it took a lot of time. Now, so what if we do it straight away on an operating ship? Okay, that will be an interesting. Now, so I explained you about number 2. Let's do number 1 and an actual cargo ship. Okay, the last time someone did this was in 1980, and actually the one who did this is Professor Ikap's PhD supervisor, Professor Molan from Southampton University. So in 1980s, he was using a small petrol boat, and he was using pitot tube on that. And since then, nobody has done it again for 40 years. And before Professor Molan, I think the first one, that actual ship, was in 1950. A team from Newcastle University, if I'm not mistaken. But between 1950 and 1980, I didn't find many experiments on that. There are some other experiments, but it's not measuring boundary layer. So it's been 40 years since someone did this in the past. Now, but we're going to do it with slightly more advanced, not using pitot tube. Okay, so this is the ship. Okay, 5 years old, brand new. This is a beautiful new ship from Japan. Sinar Morotai chemical tanker, length 95 meter, draft 5.8 meter. It's currently operating. Okay, this is her when she just leaving the dry dock. I was there when it was launching. I think one of them is my PhD student and my postdoc. One of those in the red. Okay, now so it was dry dock on just last year, March, and cleaned to bare metal, recoated, and then so what we did while she was dry dock, we put window access on it. So basically, that's what we did. So on the bottom of this ship, there is a glass window, a super strong window glass, 30 centimeters diameter at the very bottom, which is this one. Okay. And I also did an imprint to check in the wind tunnel. We haven't done this wind tunnel experiment. My PhD students are currently conducting it. And then any results from the wind tunnel will be given to Professor Ketut. So that Professor will do experiment afterwards. Simulation afterwards. Okay. Now, and then we can get all of the important statistics into this. Now, there is a prediction already. There is a correlation. So in 2015, one of our PhD students named Leon Chen and another team, I forgot from which university, a paper by Furugi in 2017, they produced a new method to estimate the drag, or actually estimating KS value just from the image. Okay, but that method is still not 100% working. It still have a few problems, but it's still better than what Professor Townsend had in 1980s. Okay, we predict the KS value may be close to 0.1 millimeter. Okay, now let's go back to the ship itself. So the ship itself, this pretty large, like I said, 95 meters. And then at 69 meters downstream, okay, we put this window access. And this is the furthest that we can go on the bottom, on the back of the ship, because beyond that, underneath here is mostly engine, okay? A lot of the engine pump and everything. Okay, so this is the furthest that we can go. And we can't go even further because there's a problem. The ship bottom starts to shrink, okay? So we don't want to have a side effect from the boundary layer, okay? So moving too far to the back may not be a good idea. So this is the best that we can have, okay? Now, and this is how we're gonna do it. So we're gonna use what we call laser Doppler anemometer. So we brought a laser from Melbourne, the University of Melbourne. It cost Professor Hutchins and Jason Monti $200,000, and every time I bring it to Indonesia, I always fight with the customs and a lot of other paperwork. But the support by ATS team, especially Professor Ikap and the other management team from ATS, has allowed us to bring this to Indonesia. But yeah. You can talk to Professor Ikap, like it was a nightmare every time we bring this. I've bring this back and forth like 3 times. Took us months. Okay. Now, and this is the situation inside the on the ship. And this is my PhD student. Okay, they are working in the pump room. Beneath him is this. Okay. There is a manhole on the bottom, 2 manhole, two doors. Okay, you can, when they're not doing experiment, it's shut closed. But when they do experiment, we put the laser over there. This is the LDA, the laser Doppler anemometers that we put on the bottom of that ship. And this is when it's in action. As you can see, that blue color, that's sea, that's water. Okay, that's seawater. And on the right, this is when they do the experiment, when they do it in the evening. Okay. Now, and this is them. So I think this is on the right is my PhD student, and the one with green cap, this is my postdoc. And here in the middle is Professor Nicholas Hutchins when they visited. Okay, And I think the one on the wearing blue shirts are the captain and the chief engineer of the ship, if I'm not mistaken. So this is last year when Professor Nick Hutchins visiting the ship. Okay, but my students told me when Nick is not there, this is them. They are hot, tired, and stressed, frustrated. But yeah, that's part of the research. It's pretty hot down there. It's 40 degree. Remember, 40 degree, very hot, humid. So for many of you students who are working on a ship, okay, will know this. Okay, so yeah, but it was a lot of fun for them.
10 minutes before question and answer.
10 more minutes. Okay, I'm gonna be finished quickly this one. All right, thank you. Now, so the ship. This is the trip of the ship. Okay, the traveling, the three trips, and this is the results. And as you can see, there's a drop. Okay, that's indicating that the ship, or although the ship is recently clean, it has increased drag. This is the highest Reynolds number ever recorded on an operating ship, or actually in any operating object. It's close to 10 to the power of 5. It's huge. It's huge. The highest Reynolds number in a wind tunnel, I think, is only like what, 10 to the power of 4 or something. So this is an order magnitude higher. We can get the delta U plus value, and we can get the KS value, which is 0.152 millimeters. So this ship, if we put it into the equation, will experience 30% increase in skin friction drag already, despite the cleaning have done properly. Sorry, I'm gonna skip this. I should have removed this, but it's just their expectation. What will happen in the next 5 years? It's just gonna start increasing when the biofouling is there. And on the same time, we're also gonna do regular checking using special camera. This is a special camera that can record image in 3-dimensional XYZ to record the roughness of the biofouling or the hull roughness. So we're gonna combine this and the laser, so that it can improve the empirical estimation. I think that's it. And then for future works, we're gonna continue the LDA measurement when the biofouling effect is getting worse. We're gonna check the roughness topology, and we're gonna analyze the data. Once we got the KS value, the KS value when it's getting biofouling, we're gonna do lab experiment also, and also CFD. Okay, this is where Professor Chut and his team from ITS will do the CFD on the neck of the ship. Okay. Now, and I think that's it. And this is the crew of Sinar Morotai. All right. Thank you, everyone.
Okay, give applause to Dr. Okay, thank you very much, Pak Bagus. It's a very interesting research book presented by our colleague from the university. Actually, we use a vessel owned by SRCM Indonesia. So this big company, it has an MOU recently with ITS. That is very interesting work in terms of science and the problem, especially at present, in a way to reduce emission, decarbonization, and so on. So we have some 15-minute cycle to question and answer. Please for the audience. Yes, please.
Thank you very much for Dr. Bagus Nugroho. I would like to ask about the camera, because we developed also camera for detecting the viewport. What the characteristic and properties of the camera? This visual camera or something like
Okay, so you're asking the camera, yeah, the 3D camera. Am I correct?
Yeah. What kind of camera?
All right. So I'll share the screen again, just this. Right, so the camera itself, okay, it's been developed by our students. So it's basically, it's in the shelf like that. It contains 9 camera. The camera has 9 lens. So it can, and then it's oriented into certain angle, okay? And then when you took a picture and then you calibrate it, because there's a 9 camera slightly angled and it's already calibrated, you can stitch those 9 images and it will generate one nice image of a 3D of the object, okay? So it can be in the shape of what they call an STL file of a 3D image object. So we are planning, so this is still under development still. We are planning to make 2, one for regularly in Melbourne Uni, and the other one will send this to ITS, where Professor Ikap will regularly using this and for a test in various ports, just to test the efficacy of the system. So what we are hoping that in the future, all we need to do is just using this type of camera, okay, so that you can get XYZ of the roughness and the statistics, which is, where is it? Which is this statistics, there you go. And this statistics, but by using this statistic, you can get KS value to predict the roughness, okay? Because if you're doing experiment all the time, it'll be so expensive, isn't it? You need a wind tunnel, that's so expensive, okay? Or if you use experiment directly on a ship, again, that's also expensive. You need a $200,000 of LDA, okay? So we hope that the result from this thing, we can create like a formulae, okay? That you can, on mathematical empirical formula, that just by using the image of that, you can get the KS value. So what we want is basically marrying the theory of what Professor Townsend wants in the 80s, a quick, fast, simple empirical estimation to get this KS value. And then once you got the KS value, you can do anything. You can predict the drag. The key is the KS value. Once you got the KS value, we can use it to use boundary layer momentum equation to get this. Where is it? Oh, this plot, that plot. Okay, so basically, we basically try to combine the best of 2 worlds of what Professor Townsend want to have: a simple, quick mathematical solution, but with a proper boundary layer theory and application based on what Professor Grigson and the hydrodynamic and fluid mechanics community has already agreed on.
Okay, thank you, Pak. Terus, Prof. Muhammad Nur Cahyadi, Professor in Geomagnetic Engineering, he worked a lot with scanning activities, needs a very good camera. And from Nur, Dr. Douglas and his colleague in Melbourne, they developed a 3D camera, etc.
Yeah. So we use the.
Interesting to be next time we can share instruments, Pak Bagus.
Yeah.
Perhaps your 3D camera can be used to help Prof. Nur Cahyadi in his work later.
Yes. Currently, the challenge with that camera is that it's not the theory of the method. The method itself is actually quite simple for the camera. It's just 9 lens and calibration. But the challenge is that we have to make it, design it so that it's easy to use by the diver. And that's the main challenge. The buoyancy, we don't want it to be too heavy because it can just drag the divers down. We need to be strong enough so it can withstand the pressure, but it has to be buoyant enough so that it can be easily held by the diver. But if it's too buoyant, it's just gonna go up. It's like so they cannot work it. So that's the hard part. The electronic part, the thing is, it's quite it's not that too difficult yet.
Okay, thank you, Dr. Bagus Kedua. Any other questions? Please, Prof.
In terms of carbon trading, is there any reward or penalty for the ship that doing increase or decrease for the CO2 emission.
Okay. Now, in terms of carbon trading and about the fuel efficiency or the economic point of view, it's mostly can be decided by the company itself. So what we're gonna provide with this information is it's a proper way to predict how much your fuel gonna cost. Because like this, if, for example, hopefully, finger crossed, if all of this works fruitful and works well, and the theory that we predict is works well in the future, if we can have this camera produced in mass produce or something like that, any ship operator can use it. So it will come to their decision. So for example, okay, I have this ship, it's already 4 years on the sea, it needs do I need to go to dry docking or not? Okay, now he can take whoever the manager is can just take a photo of the image of the ship hull, and they can calculate it. Okay, if the ship currently 4 years since dry docking, there's this amount of biofouling or roughness, how much the drag is. So he or she can correlate the drag with the fuel consumption. And this is, each company has their own data. Okay, so, and then once they got the drag, it comes to the decision, okay, this is the amount of drag. My fuel is wasted this amount. Now, which one is more fuel economy or cheaper? Shall I continue my ship moving for the next 5 years? Or shall I stop now, bring my ship to the dry dock, clean it, painting it, and then running again with a much safer fuel? Even that basic question and basic decision is still quite difficult. I've been talking to many ship operators, not just in Indonesia, but also in Singapore, Australia, and the UK. They came to the same conclusion. They just like, we don't know. We only based on the information that sometimes anti-fouling paint company recommend, but through not of their fault, sometimes the anti-fouling paint company or the ship owner, they based on the theory that was developed from the 1980s, which is still used. It's recommended by ITTC, but it's not too accurate still. So through not their fault, because the knowledge is still not there yet, sometimes they can make the wrong or not too accurate decision. It's basically that. So this is what we try to provide, is this decision regarding the anti-fouling paint quality, how much that you want to. Again, it's also the decision by the ship company. So if I have this data, okay, from the Melbourne ITS team, it says if I use this such anti-fouling paint that can hold on this kind of roughness for at least 3 years, okay, it might be more expensive, but I think it can save us fuel in the long run because of this. So that's basically it. We're adding them more weapons, actually, like to decide from the economic and energy point of view.
Okay, thank you, Dr. Bagus. I think this platform yes, yes, and this is very costly. So this way the market still can be there. Especially this way the better dog will give, but sometimes the conflicting with the operation plan, so they have to take it again. Okay. Any questions, please? Perhaps I have one question, Pak Bagus. During the, I think about 1 year, you said that we visited York in Semarang last year, and then the Sinar Monote completed, and until today not come to the dock. Okay, just stay at port and will its activities. you have information about the growth of the falling for say 1 year information in Indonesian waters based on sinar voltage. I think you mentioned the number is 0.152 millimeter. Is that the number we count during a year? Okay, please go ahead.
So yes, so if we go back to the screen, okay, so currently this is the data per June 2023. The CAS value is 0.152, and this is the hull is still very clean, Prof. So it's still very clean. We have there is no slime, no nothing. Still, it's as if new. And as you can see in here, if you can see in this plot, okay, this plot, all of these dots are from all of those three traveling from what is it, from October 2022, January 23, and June 23. They are all collapsed quite well, and that's indicating that the hull is still very clean. It's like as if it's still just new. Now, the issue is, Professor, is just last week when Isnain and Joe was checking the hull again. They didn't do any laser experiment. They just testing the 3D camera with a team of divers. They found out that there are slimes already, green slime already starting it, and some of the paint is not clear anymore. So some of the red paint has become white. So I predict that soon it will start growing with the biofouling. So we talked to Jason. Nick was still in the US, unfortunately, at that time. So Jason told me that. So Jason told us that, okay, January, I think we need to do more experiments. So I think Professor Ikap, so I think on January, Yela and Isnain will come to Surabaya, and they're gonna do experiment. And I expect, because it already has a slime now, I expect that this plot will shift down. So I think there will be a drag increase, although it will be slightly. Professor Mike Schultz told me that slime will increase drag, but it will be minute. The one that will be scary is when the biofouling starts grow. And according to Professor Mike Schultz, when there is a slime, that means it's just a matter of time that the biofouling will grow, and it will grow fast. So we expect, we expect maybe in July 2024 there will be biofouling, and we can see significant drop of this mean velocity profile.
Okay, thanks a lot. So if there's no other questions, it actually right at the end of this session, but we probably should know that ETS has very strong collaboration work with the Melbourne University, and one of our undergraduate student Japanese supposed to join you, Cindy Babagas. So correct. So the young lady to join this is what in the soon funded by LPDP.
Yep.
Would like to study you would not get this week Melbourne University place to study. It is ranked 14 now. Yes, it's very excellent university in the Southern Hemisphere. Once again, thank you very much, Pak Bagas. I think because of the time limitation, we have to finish your session, but you can continue actually stay online. But you have any other appointment, so I'll let you do that. Okay.
Thank you, Professor Ikap. I'm looking forward to see you in Melbourne, hopefully next year, yeah?
Okay, next year, hopefully.
Thank you, everyone.
Okay. Thank you. Next keynote speaker is Professor Antonio Suwanto from IPB University. If just now Dr. Bagus Nugroho is talking about the effect of biobullying on engineering application, decarbonization, and so on, Professor Antonio Suwanto will talk about the biology of the biobullying itself. It's very interesting work, I think, good for curriculum, say, biology department, or maybe environmental engineering department, and of course, all of us. Here, that is your value. Yeah, you can say.
So, first, I would like to say thank you to the organizing committee of this event, and especially for Professor our colleagues. So I would like to give a presentation here about a sustainable approach on marine biopooling. And this is actually, basically, we have to understand about this one if we talk about sustainable approach. Okay, so sini, okay, sini ya. Gimana? Sini ya. Okay, so maybe we can see here that the biofouling, by definition, is the accumulation of marine organisms on the submerged surface of the ship here. For example, here you can see barnacle, clams, and also algae. And ship biofouling actually problem since 18th century, maybe since the invention of the ship itself. Okay, so what is the adverse effects of biofouling? So this is maybe the most important is that you slow ship speeds and costly, like previous speaker who's already mentioned. This is like very costly, right? This one, and of course also increase carbon emission because we burn more fuel to just for the same distance, to reach the same distance. And another thing which is also important here, you introduce invasive species. So like in certain aquatic environment, you introduce some more organism which is previously not known in the area. This could be like predators or diseases, and this could disrupt marine ecosystem and harm the native species. So the biofouling, not just on the costly, slow speed, but also important this one, we introduce invasive species in this case. So it is important to look at the biofouling in terms of regulation, how we regulate this one, and also what innovation can be done to prevent or to control biofouling. So this is the example how that the invasive species also can be problem and or threat to coral reefs. For example, here you have a greenhouse gas emissions, and also you got direct exploitation, and another one is also pollution And this is another thing that is important from the biofouling is invasive species. So the coral reefs depends on this one, actually. The pollution, direct exploitation, or invasive species. This is actually non-native pathogen, such as introduced through ballast water of ships and could disrupt food webs and create dysbiosis. Dysbiosis like unbalance in terms of microorganism or visible organism. The invisible, the microorganism, can be unbalanced. The unbalanced, we call it dysbiosis. So this is created dysbiosis of we call microbiome, and this is induced coral death. So the death of the coral, right? So this is some example of invasive species. So this has been known that this species can be found in some area and they become a predator and then disrupt the ecosystem. Some of these sea stars also invasive species and microalgae. So microalgae also can cause coral death. So such as like this one, you see that the coral actually contain some algae, but then they become bleached, and later on, some microalgae induce the death of this coral through the displacement of the good bacteria in that coral. So this is actually what's normal in coral death. So what is the current approaches to manage ship biofouling? People already know for years actually, they can use anti-fouling coatings. You can use the coatings. This is what chemically treated coatings that are applied to ship surfaces to prevent or deter the attachment of marine organisms. So you just coat it with the toxic chemical so that the barnacles, clams, or algae die. Then keep your ship clean, right? So this is very good actually, but this is also toxic to other organisms, the marine. So this is the problem with the chemical coating that's already available. This is actually success to do some at some point, but not sustainable. So then another thing is people try to do risk assessment in terms of biofouling. This is assessing the risk of biofouling on a ship will help to determine appropriate management strategy. So for example, this ship comes from this area. This area might have some invasive species. And then we have to do something when they arrive in our system or in our port, for example. Then what we should do? So we have to do some risk assessment for that particular ship, for example. So we need a sustainable approach. Why we need this one? Like I mentioned, there is environmental concerns. Chemical anti-fouling, like this one, for example, copper. Usually they use copper-based tembaga. So they use copper. This copper base is very effective actually for coating. But then this copper also can be toxic for many organisms. So this one create negative impacts on marine ecosystem. So why we need a sustainable approach? Because of environmental concerns. And the second one is the regulatory pressure. International regulations aim to minimize the environmental impact of ship biofouling. Not just because of these two, actually, also you see that the biofouling could create drag that costs economically fuel and also economy, like you have already listened to the previous speaker. Also, why we need something surface that is as smooth as possible. So, in addition to that, we have a problem with environmental pressure. So, for example, maybe your ship can be blocked from landing in Australia because the Australian government didn't want you to land there unless you have a certificate, certify that your ship clean from this species, for example, because they think that the species might contaminate or make the ecosystem of their environment change or can be broken down because of the invasive species. So what is the trend in anti-fouling technology for marine environmental protection? So this is some of them, actually. You just do regular cleaning. This is actually something very common, right? If you clean it regularly, of course you will have your ship more or less free from biofouling. But then, if the ship is maybe small, maybe you can do it, but very in routine thing. But if it's very big, this would be very costly or maybe impractical manually. Another thing is they use heat treatment, just heating the base of that of the ship will kill many of the biofouling microorganisms. Okay, next one is next. Okay, you can. Okay, here you can use ultrasonic or electrolytic. This is another thing. How to clean up this one with more sustainable approach rather than the chemical like copper-based coating. Next. Another one is you use biofouling resistant material that has microtexture and nanotechnology. Although this is only effective for some biofouling agent. For example, it is good for microalgae, but maybe not good for plants or barnacle. Another one is, of course, you should find non-toxic coatings. And non-toxic coating, broad or narrow spectrum. If you come with the broad spectrum, meaning they can kill many of the biofouling organisms. But if narrow spectrum only kills specific, this is actually more sustainable in terms of environment if you have a narrow spectrum. But if you have narrow spectrum and the ship pass through many different areas in the ocean, you might have many different biofouling agents. So then that biofouling agent might not be able to be controlled by this type of coating. So this is another thing that we are in question. We use broad or narrow spectrums. And I will tell you later this one. We need to understand the language of the bacteria. This is the things why we need to do this to develop non-toxic coatings. Okay, so this is microtexture. Usually people try to understand from the marine organism itself. For example, sharks, like that. why they keep free from biofouling, because like the skin free from biofouling. So then they want to understand what happened with that. Why shark can keep free from biofouling, for example. Then they look at the structure, and this nanostructure from the shark skin might give an idea, insight on how we develop the coating or maybe the material for the part that can be a surface of that ballast in ship, for example. Another thing is also like you see some plant like this. They also the surface is very smooth, so then we can look at also such as lotus leaf like this to get inspiration how we develop material in terms of surface that is not easily applicable or infected by biofouling microorganism. So what is the process now? So we need to understand about this. If this is the surface, usually the surface is very smooth, but then originally you will get what we call it biofilm. Biofilm is a collection of microorganisms, and this microorganism come here attaching, and they have some like kind of gum polysaccharide like adhesive. The adhesive activated by microorganism will be attached to the surface, and the surface will create some kind of a thin layer. This thin layer, we call it biofilm. And this biofilm later will provide nutrient attachment so that attract many other organisms such as clam, barnacle, everything feed on this one. So originally, you have to prevent this from the start. Okay. So effective control and prevention could be not sustainable. Like for example, I told you about copper coating. So that one is effective actually, but considered not sustainable because they also kill or toxic to other marine organisms. So coating tools with copper or tributyl, for example, this is toxic. However, they can actually prevent this one. The first colonizer, for example, this part, but it is toxic, for example, like that. So you have the chemical, but then it is also toxic. That's the challenge. So this is the video, short video, just only a few minutes. You can see how biofilm originated or first started to be generated. Can you? Okay.
Clean abiotic surfaces immersed in liquid tend to attract and concentrate nutrients, where
themselves give some nutrients for microorganisms. A biofilm is formed when microorganisms attach to and work on and abiotic surfaces. The initial attachment is usually reversible and often involves attachment by the child, embryo, or other cell surface characters. This is followed by growth of the microorganism and production of an exopolymer, which makes the attachment irreversible. Growth within the biofilm is not uniform. Channels develop which permit incorporation of fresh ingredients and oxygen. Metabolic activities of microorganisms in a biofilm can create changes in the microenvironment. For example, an oxygen gradient can develop that permits anaerobic metabolism in the interior and aerobic metabolism on the exterior. Nutrients and pH gradients are also produced. In the natural environment, biofilms often consist of different types of organisms that function together in the cycling of the elements. For example, breakdown cellulose with certain communicating channels and it results in release of glucose and other carbohydrates, which supports the growth of non-cellular degraders. Carbohydrates are converted to organic acid in the end by anaerobic bacteria, and the methane can be integrated by aerobic microorganisms.
So you can see this one. Actually, the first important thing to understand the biofouling is to prevent the first attachment. So if you can prevent this attachment, then you can prevent biofouling with biological approach. So you understand how they actually colonize this part in this to make a biofilm. So when we talk about this biofilm, then we talk about microbial communication. So we think that human can communicate, but the bacteria, this invisible thing, they can communicate to each other. So this communication, for example, some of them creating light. Some bacteria emit light. So that when they are in a quorum, meaning that the population density has been reached at a certain number, then becomes a quorum. When they become quorum, they can emit light. So the bacteria understand like how you do the meeting, right? If not quorum, then we cannot make a decision. The bacteria also think like that. So if not quorum, they cannot do to make a decision. Like for example, in here, this is we call quorum sensing. The quorum sensing is important. So that's why many people now try to understand this, so that we can block the quorum sensing. So if there is no quorum sensing, the bacteria think there is no mass, no other friends with them, so that they cannot attach. So this is the idea from there. So you see this one, actually, for example, this type of squid, this small squid emit light, but this light is from the bacteria. But then from there, we can understand how the bacteria communicate. Okay. So like this one, the communication of the bacteria led us to understand about studying bacterial communication, especially with this species, we call it Vibrio arvei. Because this bacteria, if you grow it, then you can see light in the dark, thing like this one. Okay, so basically like this, the communication. So if in high density, they have a group behavior. But if only in very low density, the bacteria only alone like this, they are actually have individual behavior. Group behavior is different from individual behavior. For example, the group behavior, they can be very angry and they can excrete the gut aggressive, for example, like this one. But if they are alone, they are very good. They did not do anything. So just like human, sometimes human change. If you are alone or if you are in mass like that, so your behavior can change. So this is actually why the bacteria can detect their number. So for example, they know this is very high. This is because they emit special molecule. This molecule, if they are only one cell like this, only few. But if you have many cells here, the blue one like that, they emit this red triangle in a large quantity, even though this is the same volume. But you can see, you can get more this red triangle, and this one is the language. They know, okay, the population is already high. So many people want to block this one. If you block this, even though the number of bacteria is very high, like this, but if there is one low, then they behave like normally. They did not produce biofilm, for example. So this is actually just the chemical structure of that language. So how they do the communication. So this is I just give you example how quorum sensing like this. This is bacteria, only 4, and they emit this compound, which is actually the signal. They emit the signal, and then later they proliferate. Okay, the bacteria become. You have a lot of the cell here, the bacteria, and then you, of course you have more of the signal molecule. Because they have more of the signal molecule, like you are in this room, if you have so many people, maybe you have sweat. Then finally you can smell the sweat, for example, like that, this compound. And then change the behavior. They call it auto-induction. And that one you can see from blue, they become red. So they change the behavior, just like human. If you are in a mass, you can be angst and becomes very powerful to do something compared to only single individual. So this is the process that we try to develop for anti-biofouling later on. So this is like this. Okay, so how to prevent bacterial communication? This is actually the most important thing. Anti-quorum sensing is how to prevent bacterial communication in here. So if we can prevent this one, the first one, then we can develop the proper biocontrol. So you just block the first one over here. Okay, so this one, how the mechanism and how we prevent the this communication. There are several ways. Like for example, you can add some compound that can compete with this, or what we call it quorum quenching. Just so finally you block the communication or signal or the molecule itself. So they call it like in this case strategy how to do it. And people now studying this. So then when we can come up with the molecule that can prevent the quorum sensing, then you can block this biofilm. This is the biofilm, the origin of the biofouling. Okay, so this is more on the molecular aspect, which is actually many people try to understand about biofilm formation, and then finally later will be used for control. Okay, so basically you can see here, if like this, you have quorum quenching minus bacteria, and this one you have. They have quorum quenching. Quorum quenching is meaning suppress or stop or break the quorum sensing. So if there is no quorum sensing, the bacteria cannot do or make the biofilm. So for example, in this case, we can see some bacteria can disrupt the biofilm. This is the biofilm, but you add bacteria, and this one, the biofilm will gone. So you can imagine later on, for example, some people can put the sheet with this bacteria, and this bacteria can prevent the formation of biofouling. So this kind of research still ongoing. Quorum quenching bacteria can be used to inhibit the biofouling of membrane in this case. But you can do it later for this part. But still, this one ongoing study. Practically, still not available in the market, the real biological solution for this one. Okay, so this is what I also mentioned here, that the bacteria also important for the pathogen infection and responsible for the coral death. So you can see the coral death. This is because of the bacteria that is normally there, may be disrupted. The disruption, whether this one is because of a chemical or something, will make the disruption on the ecosystem or coral ecosystem itself. Okay, so I think I will just skip to the so many. Oke, ya, yang itu. No, the slide. Just the last slide. Okay, so in principle, I think in this case, I don't want to give you the detail on because I have the detail for this one, but probably most important is in terms of sustainability, we have to understand the biological formation of biofilm because the biofilm is the origin of the biofouling. So to understand that, we can develop strategy how to prevent biofouling. So the conclusion is ship biofouling has economic, of course, and environmental impacts. Sustainable approach offer cost saving and protect the environment. But this one we need to understand the microbial community. Okay, to get this one cost saving and protect the environment, we need to have a deep understanding of microbial community roles on biofilm formation. Because this biofilm formation could lead to a sustainable biofouling prevention. So this is, I hope that you understand, of course. But if you are interested with this one, this is ongoing research. Actually, hot topics in terms how you find the compound that is environmentally friendly for that one. So, call to action is to adopt sustainable biofouling management practices to protect the environment and improve efficiency. So this is actually the one that is important later on. Okay, so the next slide, actually, yeah, before me, the last one. Okay, so this is actually just to show you, this is Louis Pasteur that worked on microorganism and also many types of chemicals during that time. And they see here that it is the microbes who will have the last word because that originally also you have the microbes from the beginning. So they have been here almost 4 billion years. So that's why we will have the dump like COVID first. You can see it like that is part of that. And this is biofouling. We talk about biofouling. What is the origin? The origin also something that is you can see, you cannot see. That is the bacteria. So that is what they call it because in this world many problems originated with them. That is maybe good or bad. Many of also the good one. Okay, so I think that would be my presentation.
Okay, give me the browser. The picture is very interesting. The bagus keberawang sebuah game effect. And the problem tells us about how we can communicate with biology, with bacteria, in order to manage the doing and then prevent the bad effect of biology. Okay, now Q&A session. Please, audience, colleagues from the biology department.
Sini ya.
Okay, thank you. I would like to introduce myself. My name is Yudha. I'm from Biology Department IPS. And thank you, Professor from Anton. Thank you for your interesting lecture. I had a question, Professor. It's for this person to manage the by building bacteria. You know, bacteria is finds organism, I mean, possible organism, right? And how to manage the number of the bacteria? I mean, it is maybe I mean, the bacteria community, I mean, community of the bacteria is very vast, is very large, and how manage the number of the bacteria, Professor? Because it maybe it's make dangerous to the water and the other organisms in the oceans. Thank you, Professor.
Thank you, Ibu, for the question. I think it's very, very a good question for that one. Yeah? But we need to give explanation, of course, for this one. So, okay, in nature, we have actually many bacteria. Also in our skin, we have also bacteria. But we see why the bacteria also cannot proliferate, cannot just be growing like this one. Because they also have limited nutrient. So the nutrient is their limitation, the most important. So for example, even though you give them in a certain environment, that environment will have a limited nutrient for them. So they cannot just divide and then become like that. Theoretically, yes, if you put it in the fermenter or in the kind of vessel, tube like that, you can make small tube, bigger tube, then the bacteria will grow because you give the nutrient. But then in nature, the nutrient is limited. And the other one is they have a lot of enemy too. The bacteria has virus in it. So that the virus will infect them also. So this is actually another challenge. And many also, some smaller like protozoa, like that amoeba, they eat the bacteria. So that in nature, you cannot see the bacteria growing by itself because limited nutrient. They have also the virus infect them, and also they have also other organisms eat them. They eat the bacteria. So if we that's why when we, for example, eat Yakult, you drink Yakult, right? So the Yakult bacteria will not all of them survive and go to our intestine because they will die during their process because of our stomach very acid, right? So that they will die like that. So finally, we have only limited number. So, but your concern also creating a problem also for the development of this. Even though you can have bacteria that can prevent biofouling, how you will apply it? See, this is the problem also. So probably later on, what happens is people will extract the bioactive compound, meaning like why they prevent, probably like antibiotic, like that, something like similar to antibiotic. Then this one we can extract and then we can make a coating for that one. And this coating is more sustainable rather than the toxic chemical. So this is, of course, we need to develop. But first, we understand there are some bacteria can prevent biofilm formation. So that bacteria might be interesting to be developed for our intention, right? To make like to control biofouling at the end. Maybe some.
Thank you, Prof. Anton. Is there any other questions, please? Yeah, I have one question, sir.
Yes.
At the beginning, you said that the easiest way to protect from biofouling is put good coating. And sometimes when we use pre-butylene, which is very toxic. But just now you mentioned that we need to cut the nutrient for the bacteria or the biofouling, we can prevent the growing of biofouling. So, which one is maybe better, more natural, and how we can do that? Especially on the second approach. Perhaps we can save the environment because we need to use coating which is toxic.
Okay, so I think that is a very right now still very difficult to answer, right? Because probably for the shipping industry, if they don't have any restriction, they will just do the toxic one, the general one, because that is cheaper, more practical, they like kill everything. So it's better people don't care. But if now there are concerns that this chemical might also have negative effect to the environment, then they will get penalty. Then they have to go with the more expensive, even though this one may be more expensive because this is, I imagine, probably this one is organic. And because they are organic, they will not last long like that. So maybe you have to do that like a rule, some period, maybe once a year you need to quote again like that one. That becomes more expensive, right? That compared to the chemical coating maybe last 5 years, I don't know. But the development of this organic that is more sustainable, probably more expensive, right, compared to the chemical one. But they are maybe more biodegradable, easier to degrade. Yeah, it is very difficult right now. I think that for now, people will just continue still using the available coating as long as there is no penalty for them. But if you put high penalty, then they may be thinking about this other approach, other alternative that I mentioned to you, still ongoing. Yeah.
And at the beginning, you also mentioned that one of the government in the world, in Australia, asking for the certificate of biofouling cleaning. What is the purpose, Prabhakar?
Probably this one is to protect from invasive species. Yeah, maybe like they have many coral, maybe Great Barrier Reef, and Australia is one of the most stringent, right, in terms of protection. So maybe not just that, even plane also arriving to Australia before they spray with super chemical like that. So maybe for ship they want to do also some regulation for this one. So for us actually we have to do also something like that actually, because we have a lot of marine environment that could be prone to invasive species by allowing, I don't know, the ship from everywhere of the world coming to Indonesia, for example. Then you will see many of these species that is maybe not available in the area, and they become invasive species, predator, or something. Like the fish I show you, that one is considered like eceng gondok now. Eceng gondok is something invasive, right? In Indonesia, before this one is not come from here. This one exotic plant, and those fish they call it what, lion fish or something like that. This one is actually invasive.
Okay, thank you, Prabhakar. It is very beautiful when you talk about science and the detail of it. So I think this one has to be investigated by us, IDF, colleague from biology with this problem.
and also from other engineering department. So for your information now, the International Maritime Organization is concerning with the biological problem of Anton. It's that, and there will be the first forum in Busan in October. So the information is available on the internet. Perhaps if you would like to participate, stay tuned in October next year in Busan.
Yeah.
Okay.
Maybe one thing.
Yes.
Would like to mention. You see from presentation Pak Agus, this one actually he mentioned this is non foul, right? No biofouling. This one just only roughness. It's already costly, right?
Yes.
In that case. So you can imagine this one with the fouling. So of course very costly because he already used only the rough material, but meaning still clean, no fouling.
Yes, and actually the vessel actually protected by certain coating, but the ship actually mostly operated properly. So that's one way to avoid the grade of falling. We use the vessel more. Don't stay long at port. It's one of the ways. Yes. So the problem because this company sometimes is very well known shipping company. So they are very excellent business.
That's maybe good SOP, right?
Yes.
To do that because that means maybe during that docking, the biofilm is easy to form.
Yes, I agree with you. When we look at our Navy fleet, for example, in Perak, and there will be a lot of problem with that because they only use only 30% in a year. Any other research? We still have another 5 minutes for question and answer. Kemudian, kalau Prof. Biology, perhaps you have any questions to Prof. Anton? Okay. Maybe from online side, please could you connect to a participant online? No questions from them? Online. Okay. Well, because no other question, I think yes, Udian, please.
But now we already have some of invasive species in our cluster. Maybe you have some suggestion how we solve the condition of our cluster that right now is already contaminated with so many invasive species. Maybe from the microbiology aspect, we can do something for the native species from the invasive species. So we can get the balanced ecosystem.
Yeah, thank you, both. Yeah, I think we have to do the mapping. Which area in Indonesia still considered pristine, meaning non-contaminated? For example, maybe some area is still very isolated. So this area must be protected, and then we should guard it, that area. Maybe whether, for example, Molucas area, Maluku, or maybe some, we don't know. Maybe you are from the this field, maybe can coordinate with the people from the marine study or something. If that area, Raja Ampat or something like this one, must be highly protected, I think. Like Great Barrier Reef, Australia, highly protect the area. Cannot just any ship coming, and some ship that is need to come, they have to have stringent regulation. Maybe from you have to get permission from maybe from I don't know in Indonesia where it's supposed to be. And we have to think about this regulation. Otherwise, all of our marine system will be like a disaster, right? In this case, yeah. So your concern is very, very, very important. So right now we cannot do too much. Just protect the area that is still pristine. Definitely, like Surabaya Port is not pristine, maybe, right? But some other area that you think you need to protect, we have to do something. So like maybe mentioned before, maybe we have to initiate some regulation for our marine environment like that. It's very important to initiate like this one. Maybe a group in this field of study together work with maybe Department of Fishery or something, then make together some regulation. Maybe you can use certain model first. This one, just one. You go work with that, especially like this usually can get funding, right? Many of the money, but just protect this area and focusing on that. For example, like maybe ITS work with the area in Raja Ampat. So Raja Ampat, how to protect that one? Just focusing there and have the funding. So then become a model for Indonesia. If that is good, then we can be very successful to protect that. I think it's very important. Yeah, good insight.
So, good question.
Yeah.
Also, I think we should agree with Anton. We should protect Raja Ampat. Perhaps we remember that 2 or 3 years ago, there's a big ship really went to Raja Ampat and provided some of the marine environment there and destroyed and what the fine is nothing, very small. Secondly, we should receive a lot of money to rehabilitate them. And I heard I think I should work to protect them. Recently, I received a picture from a colleague, from General Dr. Mariki Boots. Maybe Panda no, she's from Bochum University and worked with colleague at PPB. Dr. Mariki Boots from Bochum University in Germany. So she lives in Banda Island, teaching local people on how to work with the sea environment. And one of them wanted to seek the biology. So he sent me a very nice picture about an animal. I thought it was something biota. It is biology. So it could be interesting. Yeah. So if you don't protect them, maybe in the next 10 or 20 years, Raja Ampat can disappear from biology. So it is our work, as I agree with Prof. Anton. Kemudian yang ada colleague from biology, please talk to people in Raja Ampat, maybe the government. We have to save Raja Ampat. Yeah, from other. Thank you. Okay. Thank you once again, Pak Anton. I think the time is over. Okay, please give a big applause to Prof. Anton. If we can take a picture before we come to the next session in front of you, Prof. Anton, Prof. Nur, and others. Prof. Harim, okay, please come to the front and take the picture. Yeah. Ya, Pak. Sampai ya, Pak.
Terima kasih.
Semuanya.
Cepat sedikit bisa.
Ya. Yes. Mau ada yang berdiri di sini, silakan di atas. Perawatnya di depan.
Bapak di biologi ya? Belajarnya di kelautan.
Sebenarnya ada di atas.
Ini karena Pak.
Oke.
Ya, monggo.
That will be presented by Coach Gary to this. Penyerahan sertifikat dari Profesor Muhammad Rucayadi ke Profesor Arya Utama.
Ini malah bisa lebih rileks.
Iya.
Oke, terima kasih.
Sebagai moderator dari ini bagus.
Yes. Ibu di
Thank you. Now, as we move on, let's go to the next agenda, which is first presentation. One of the condition examples. Let's see if present you to know about education. To the participant, you can go to the presentation as your task in the series calendar file. Thank you.
Sekali ya sepertinya ya. Oh iya. Kan kalau ruangan dan ruangan ini.
Mas Rana, nggak tahu backgroundnya. Nggak dipasang background. Masih komunikasi kok, And has a mitigation. Okay. There are 4 presenter. Yeah. I will call you one by one. Yeah, before start the presentation. The first presenter is. And then Bapak Widya ask. Okay, thank you Bapak. And then Bapak Trio Adriansi. Okay, thank you Bapak for coming. And then the last is Ibu Nur Hidayati. Okay, thank you Ibu. You are the woman, yeah? Okay. Okay. And we are with the code of instruction, each presenter will deliver the presentation for 10 minutes, 10 minutes, 10 minutes, 10 minutes for presentation and 5 minutes for Q&A. Okay, fine, deal. Okay, we will start our agenda.